In a recent episode of Hidden in the Stars, we examined the Carrington Event, which I will leave linked here, which we described as the most intense geomagnetic storm in history. While reading the comments section, it was pointed out that there were other, more powerful storms for us to explore if we expanded our horizons a bit. So, like the explorers of old, we set off to see what else we could find on this place that we call home, and that led us first to Miyake events. A Miyake event is an observed sharp enhancement of the production of cosmogenic isotopes by cosmic rays, according to a quick Wikipedia check. They were named for Japanese physicist Fusa Miyake, who was the first to describe the event in 2012. As you can see here, when cosmic rays enter our atmosphere, they collide with gas molecules. When a free neutron knocks a proton out of a nitrogen atom, it forms carbon 14. The trees breathe in these isotopes, which are then stored in the growth rings. While studying the rings of a 1900-year-old tree, her research revealed that a massive influx of cosmic rays caused a big uptick in carbon 14 isotopes in a tree ring dated to 774 775 CE. Other teams confirmed the spike in wood from Germany, Russia, the United States, Finland, and New Zealand. Whatever happened, it affected trees worldwide. But the evidence wasn't just located in trees. For each of the confirmed Miyake events, researchers have found matching spikes of beryllium 10 and chlorine 36 in ice cores. The event was backed up by an account in the Anglo-Saxon Chronicle, which stated, AD 773, quote, "This year a red crucifix appeared in the heavens after sunset." The verification of Miyake events has enabled archaeologists to establish benchmark years from which they can date historical events or objects. For example, Landsaw Meadows in Newfoundland was dated from a Miyake event in 993-994 CE. While the Carrington event was undeniably a powerful storm, the one discovered by Miyake and her team was 10 times stronger. But was it the most powerful? The answer is a resounding no. That title goes to a storm that occurred over 14,000 years ago. Discovered in 2023, the largest known Miyake event was reported between 12,350 and 12,349 BCE. It was identified during a study conducted by an international team of researchers who measured radiocarbon levels in ancient trees recovered from the eroded banks of the Druzé River in the southern French Alps. According to Kseniia Golubenko, a postdoctoral researcher at the University of Oulu in Finland, quote, "Compared to the largest event of the modern satellite era, the 2005 particle storm, the ancient 12,350 BCE event was over 500 times more intense, according to our estimates, and is shown to be the largest presently known extreme solar event." The 2005 particle storm that Golubenko refers to is the Gannon storm, which took place on May 10, 2005. Several effects were observed, including auroras visible in areas that don't normally see them, such as the image here from Mazatlan, Mexico, high voltage lines being tripped, transformers overheating, GPS-guided tractors going off course, transatlantic flights being forced to reroute, satellites going into safe mode, deorbiting, or requiring more power to avoid collisions with space debris. In addition, the Gannon storm created two temporary extra radiation belts, shown in purple here, sandwiched between the two permanent Van Allen belts. These new belts show the potential impact on the Earth's magnetic field in the event of a severe solar storm. Remember, too, that the event from 12,350 BCE was over 500 times more intense than this one. Since there were obviously no observable effects from that storm beyond what we can see in ice cores and tree rings, we moved, therefore, into hypothesizing the potential impacts of a storm of that magnitude. Such effects could include increased UVB levels, which would lead to increased rates of sunburn and skin cancers, eye problems such as cataracts and snow blindness, potential DNA damage in humans, impaired aquatic environments, since UV radiation inhibits photosynthesis, a partial or total loss of a communication satellite that could disrupt telecommunication services, emergency response systems, financial transactions, transportation networks, and weather forecasting abilities. In the words of one scientist quoted in Live Science, quote, "A similar solar storm today would be catastrophic for modern technological society." As other researchers have noted, quote, "We still have much to learn about the behavior of the sun and the dangers it poses to society on Earth." Thank you again to those viewers who suggested a deeper dive into this subject. Check the description box for links to some suggestions for further reading for those of you who wish to scuba dive through the data. As always, we are interested in reading your thoughts in the comments section. Perhaps this storm needs a name. What do you suggest? Catch you next time on Hidden in the Stars.